Question 3 of the assignment 16.1.16. It says disk has an angular acceleration which is 8 radian per second square and the velocity omega 3 radian per second. So it is the angular velocity at the instant shown. So if it does not slip at A, determine the acceleration of point B. So this is a disk, it is rotating, and there is a particular instant at which the angular acceleration and velocity is 8 radian per second square and 3 radian per second respectively. And as you can see from the direction, it is counterclockwise, and there are points, point A which is the ground, and the disk which is it is touching the ground, and there is B point as well. So we have to find the acceleration at point B. So the B has an angle of 45 degrees with A. There is a center point over here which has a radius 0.5 meters. So these are the givens, and we have to find the acceleration at B. So for that we have to use a reference point, like for which we know the acceleration, and then we can use the relativity to find the acceleration at B. So we don't know the acceleration at A or C, but there's a point O at the center, so we can use that. So as we have the angular acceleration, we multiply it with the R, which is the radius, so we get 4 meters per second square, and it is towards the left side, because like the over here the direction is counterclockwise of angular acceleration, so the acceleration at the point O must be towards the left side. So we know the acceleration of our reference point now, then we can use this formula, which is acceleration at B is equal to acceleration at O plus alpha multiplied by R B relative to O minus omega square multiplied by B relative to O. So we know that it is in left direction, so we use negative sign over here with I, and alpha is in K direction and it is 8, and as it is counterclockwise, so it's positive. And then we have to break R over here into I and J components, so we draw this triangle. So as you can see, point B over is here, so if we draw a straight line towards over here, we can find that these two lines will be perpendicular, and this will create a right angle triangle. We know the hypotenuse over here, which is 0.5 because it's the radius, and the angle is 45. So if it's 45 over here, it's 45 over here, so we can simply use sine and cos over here, and it's relative to B relative to O, so you're coming down and towards the left, which means that the sines over taking this angle, so with taking this angle, which means that the 0.5 sine 45 degrees I in I direction, which is this side, is positive, and the J1 over here is negative. And omega we know from our question, it's 3 square, and then we simply put the RB relative to O components over here too, and then we simplify our equation, which is minus 4i plus, we multiply this K multiplied by makes J, and we multiply the numerical values over here. We do the same over here too. K into J is negative I, but the negative over here cancels, so it comes positive over here. this means negative, and this negative and this negative cancel each other, and it's simply calculation. And we get AB in form of its I and j components. So we have to find the magnitude and the direction, so we just use the magnitude for, we just square the I and j components and then sum them up and finally take a square root of them, which is 1.42, the final magnitude we find in meter per second square. And then we have to find the angle. So the angle we find is, we have our vertical component is always at the top divided by the horizontal component, and we take the tan inverse and we get minus 54.1 degrees. So as it says that minus 54.1 degrees, it means that it is not in the first quadrant, and also we know that the y-axis it's positive and the horizontal component we take as horizontal, so it's x-axis it's negative, so it is in the second quadrant. So this angle is, we are able to find is 54.1 over here. So the direction we have to use the quadrant, so it's basically trigonometric used in it. So whenever we get a negative sign or both of the components are not positive, so we have to use this method to exactly know where the direction is. So finally we get the acceleration at B is equal to 7.42 meter per second square with direction 54.1 degrees, and it's towards in the second quadrant.